In this first video, I'm going to show you how to load data into R and make a plot very quickly. Let's first go to lesson 1, and this is our data. It's from ENCODE's HMM, which is their hidden Markov model, where they try to predict where different regulatory features in the genome are, such as enhancers and insulators and other things like that. So that's our data set. And then we have our script here, which we're going to go into R, and we're going to load that up. So when you install R, you want to install R and RStudio, and then you just open RStudio and it'll find where R is, so you don't have to deal with R directly. And RStudio is really helpful for working with these files and running them. So first thing we do is we go up and open up our file, go to lesson 1, and pick the R script here. So it ends in .r so that R knows that it's a script that it can run. So it opens up here, and if you have different colors than I do, then I believe you can go up here and change that under RStudio and then Preferences. You can look at the appearance and change different things, and I think I've picked Cobalt here. And so that's why mine looks a little different, just so it's easier for you to see than if it was white. But that's totally a matter of preference. So we have our script up here, and we also have a console down here where you can type in things and see them happen right in front of you, like 2 + 2 = 4. Awesome. We also have our environment up here that's going to contain all of the variables that we have set, so we'll look at that a little later, but you don't have to worry about it so much. And over here we have a few different tabs that are very useful. First one is Files, and you can see here that I'm already in the right place. Otherwise we can click around here, go out to different folders, click around until you find where these lessons are on your computer if you've downloaded them. Or you can just follow along. And so I'm here where all the lessons are, and so I'm going to go over to More and say Set as Working Directory, and then we're all on the same page. And so you can see it actually comes over here, pops up in the console, so it just ran that. It set the working directory to the desktop. But this graphical user interface in RStudio just did that for you, so that's awesome. So now we're in the right place where the data is sitting. And what we'll then do is get started over here. So the first thing we have to do, now that we have set the working directory correctly, is, I'll make this a little bit bigger. We're going to use a package called ggplot2, which is really good for making plots, and the way that you load in these packages is to go Library, ggplot2. The way you can run this line of code is to hold down Command on your computer if you have a Mac, or if you have a PC you can hold down Control. So hold down Command and then click Enter or Return, and then that's going to run it. And so see how that line of code that I just selected now moved down here. And so it ran in the console. So the console is like the log of everything you've done so far. So if you're not sure if you've run a line of code yet, you can see it down here. And you can also type the same thing in down here and it'll have the same effect. The reason we use the scripts up here is so that we can keep an account of everything that we want to do, so that we don't have to type it in every time. So instead we have it in order, and it's a little bit more organized that way. So next thing I want to do is say which file I want to use. And so this is a string right here which has the quotes around it. And so you need those quotes whenever you're giving R something that is a series of words or a file name or something like that. So you put quotes around your file name, and because we set the working directory to the desktop, you have to put in the path. So we put like lesson 1, that's one of the folders over here, and then within lesson 1 we have encode hmmdata.txt, and these underscores are important. If you put spaces, it's not going to recognize it, right? So it has to match up exactly with the file name here. So you can always just like go over and like highlight this in Finder, for instance, and then you can make it match up exactly. So we set this file name, and this little arrow thing here essentially assigns this string of characters into the variable called file name. So if we go Command Enter on this line, it will load in down here. So now, if I wanted to see what file name contains, I can write file name up here, or I'll show you how we can do it down here as well. Just type in file name, and down here you just hit enter because you're like writing into the console. And now you can see that file name contains lesson1/encode hmmdata.txt. So we now have a variable that has this string in it. What we next do is we try to read in this data set. And here we use a function called readCSV, and you always need these parentheses when you're using these functions. A function is something that helps you do something that would otherwise be a little bit harder to figure out yourself, such as how to read in all the data from one file in a format that makes sense so that we can work with it in R. It's really nice to have these kind of functions that help us do this. So readCSV is one of those functions, and all it needs is the file name, which we have now. So this essentially is the same as putting this in where file name is. And the separator is the /t here, where this is the slash that is above your return or enter key on your keyboard. And this is a code that means a tab. And so that means, like, instead of putting in a tab like this, see, that doesn't really work, we have to type it in like that. And so, yeah, this code means a tab. And so that means that when you're reading in the file, we want to separate it at all of the tabs. And here, header equals false means that the file doesn't have a header. Now, if we want to take a look at what the file looks like, we can go back out to Finder, take this, put it into your favorite text editor or whatever you want to do. If you double click it, it'll open in some program. I have Sublime Text 2 here that I use for a lot of things, and so it opens up in this. But if you haven't picked your favorite text editor, it'll probably just open up in TextEdit, which is on all Mac computers. Or if you have a Windows, it'll open up in Notepad or something like that. So here I can see, we see what the data looks like. It doesn't have a header, and so header equals false over here was correct. Back in RStudio, header equals false, good. And we said that it was separated by tabs. So look at that. Yeah, there are tabs between here. Instead of just having a single space, and instead of having commas separating the different columns, for instance, we have tabs. So that's important to note. And so that's all the information that we need to give. The file name, the separator, and whether there's a header. So now we read in this data. So we go Command Enter on this line. And it takes a little while because the file is a bit big. And now that we've done that, we can take this other function called head that looks at the top 6 rows or so of the my data thing. And so here, this is what the top of our new data frame looks like. So data frame is the special container for data. It's like a data structure that has rows and columns. So here the columns have these weird names because we didn't have a header in our file, and so it doesn't know what the headers are supposed to be, so we have to give it that ourselves. And we can see that there are also different rows, and these just have numbers, which is fine. And yeah, so this is what our data looks like. Now, instead of keeping these V1, V2, V3, etc., we want to give names to some of the columns. So what we can do here is let's look at what happens if we just run this part. So if you highlight a part of the line, instead of just running the whole line, it will run this part when you go Command Enter. So let's see what happens. So these are the current names. And if we only care about some of the columns, like in this case, I only care about the first 4 columns because I don't really know how to plot the other ones. These seem to match up pretty well, like V7 is very similar to V2. So we have like a chromosome, start, stop, and a type, and then I don't care about the other columns. So if I just want to rename the first 4 columns, I can say names for my data at columns 1 to 4. And if I highlight all of this, it'll show you what the first 4 columns are now named as, which is B1, B2, B3, and B4. And so this is like a list of 4 different things. And so we can replace those 4 things with 4 other things, like these. So if I highlight this part, it shows you that it's Chrome, Start, Stop, and Type. So we're essentially taking these 4 and replacing them with these 4. And so that's what the arrow does. Just like when we were assigning the file name before, and when we assigned the output of this function into my data to store our data frame. So when I run this, it changes the names of the columns. And so now if I go head my data, you can see that the columns have been renamed, but just the first 4, right? Because we don't care about the other ones. Awesome. So now the data is a little bit easier to work with. And so now we're going to make a plot and see what that does. So we loaded in the ggplot library before up here at the top, right? And now we're going to use it. So there's this function called ggplot, not ggplot2, but just ggplot. And this is meant to make plots. And it has kind of a funny look to it, but it's really, really useful. So what we give to ggplot is our data, the data that looks like this down here, right? Beautiful. And then we tell it how we want the data to be plotted. So in this case, we're trying to make a bar plot, which is what the plus geom bar says out here. That means we're making a bar plot. And this AES here, that stands for aesthetics. And here we provide it with what we want each part of the bar plot to mean in our data. So that means that the x-axis will contain the chromosomes. So that chrome matches up to the column name for this data set. And then fill equals type means that the fill color in our bar chart will be the type column over here. All right, and plus geom bar makes it into a bar plot. So if we run that, if we go Command Enter on this line, then it's going to make a bar chart. So you can see we have a lot of things going on here. We have an x-axis that says Chrome on it, just like we asked it to, right? X equals Chrome. We have the fill equals type, and so the color is determined by the type. And the legend over here shows type along with a lot of different colors and what each color means, what the type was called in our table over here. In the data frame, the type column had these different categories in it, and those now have different colors. Awesome. And on the y-axis we have counts, because we're making a bar chart. And so since we didn't give it any y values, it assumes that we want to make a histogram, or in this case, a categorical bar chart. It can actually make both, which I'll show you in a future video. So yeah, so for each chromosome on the x-axis, it now just stacks them up. And so the y-axis is the count for each type, and then they're stacked. So this is pretty cool. I like it a lot. So we're going to make a lot of changes to this plot in future videos because it looks a little bit funny, but you can see that there's an easy way to make plots very quickly here. So now I'll show you how you can set up a system that lets you save your plots in different file formats very easily. So what you would normally do to save plots here, I'll show you the long way, is you have this plot, and then you can go up and click Export, save plot as image or as PDF. So let's say save plot as image. It then takes you here where you can take a look at it. You can set like the width and the height and so on. And that doesn't always work very well. But you can also choose different file formats here. And it automatically sets the file name as rplot. So every time you want to do this, you have to go to like directory, choose where you want to put it, like here, and then you have to give it a file name. And so let's say that you make a lot of changes to this plot. Every single time you want to see what it looks like when it's saved as a file, because sometimes it doesn't look exactly the same. You have to go in, give it a file name again, and save it. And so let's do that. We'll say our plot here, that's fine. We'll save that. Then I'll go up here, we'll open up our plot and see what it looks like. Great. So that's nice. It's kind of blurry when we make it big, actually. But it looks okay. But here's a much faster way of saving a plot like this. So let's say we want a PNG. What we could do is use this function PNG, and then we just give it the name that we want the file to have. And so every time you run this, if you just like run the whole script, like all of this, if you run this whole script, it'll save this plot automatically with the same file name every time. So you don't have to go in and do all these clicks like through and find the directory and all that stuff and save the plot. You don't have to do all that each time. You just run this, so it's already written. So it kind of creates a system that's going to automatically save your plots for you. And so in here, we just say, like, after PNG with the file name, all you have to do is make the plot exactly as you did before. This line is identical to the one up here. And then we just use this dev.off to say that we are done with making this plot. And so now it officially saves it to the file, and any changes you make after that is not going to affect the file, which is good, because then we can make different files. So you have to start the plot, make the plot, and end the plot. And so this is always dev.off, it's nothing different. So let's run that. So you can highlight more lines at a time than just one. You can highlight however much you want. You can highlight the whole thing, like go Command A, highlight all of it and run it. But I'm not going to do that right now. So I ran these 3 lines. Let's go take a look at whether we have a PNG file now. Go to desktop, lesson 1. So I named it plot.png over here. Let's open this up. And we have a plot. So this was saved automatically. So let's say I make some changes in here. Then I just highlight these 3 lines again, run it again, and now the changes have been saved automatically. That is a lot faster than going in and clicking export and stuff like that every time. Another thing I can do is save in different file formats. So we can save a TIFF file, a JPEG. All you have to do is change this function right here. It's TIFF. And then you can name it plot.tiff, just so that when you open it, the right program gets called. And JPEG. And we can also save it as a PDF, and all of these just kind of work. So you can do all this at once, and now you have your beautiful plot in every file format imaginable, so that when the journal asks for a file from you as a PDF or a TIFF or whatever it is they want these days, then you can just give it in that file format, and it all works out great. One thing that might be a problem sometimes is that the resolution is not always great. So you have this plot.png here. If I wanted to make this really big, like put it on a PowerPoint slide, for instance, and show it to thousands of people, this doesn't look great, right? It's really blurry. One way to solve that is to use the PDF format instead, where when you make it bigger, it stays really crisp, and that's because the PDF format doesn't save things in the form of like pixels. It actually saves these as kind of primitives, so it knows what the text is and it knows what the colors are, and it saves it as like rectangles and text and other things like that, instead of just saving the pixels. So that's one way, but sometimes you really just do want the PNG so that it stays looking exactly the same as it did when you made it. And for that, we can just make higher resolution. So when you have this PNG function, or any of these other image ones, you can put numbers after here, and so this is, I think, the this is like the x-axis and y-axis sizes. And so here I just made both of them 1,000 just to make it really big. And that's all you have to do is just say like the file name like before, comma, one direction, comma, the other direction, how many pixels you want, and then we run it again. And you can just experiment with this. If you want the file to be not very tall and very wide, then you can do that too, and so you can just experiment, see when it comes out right. So here I saved it with a different file format, a different file name here. See, I did like plot high res, just so I can compare my different plots to each other. And so now that I made it higher resolution, you can see a lot of things changed. Some of these things got much smaller. The labels on the x-axis are now really hard to see, but they're spaced out, which they weren't before. So that's nice. So when you have it this big, you might want to make the labels bigger as well to match. So there's all these little things that you might want to change just to make it fit better with a high resolution. And I'll show you how to do all of that in the future videos. But for now, this is showing you that it's possible to load in data really quickly, take a look at it, get it organized, take another look at the data, look how pretty it is. You can make a plot in just one line, and if you want to save that, you can save it in different file formats automatically in the same folder that you got the data from, for instance, or if you want to make a special plot folder, you can do that too. And so we save all these plots, you can save it in different file formats, you can increase the resolution, you can do all these awesome things, and it just gets saved for you automatically, so that if you want to make a small change, you just highlight all the lines and run it all again. And you wait a few seconds, and now you have new versions of all of your plots saved, and that's all you have to do if you change your data, for instance. This is something we do quite often. Maybe you've made some changes to the data, or you want to make a little tweak to the plot or something like that. And then you can easily just rerun it, and now you get fresh plots in all the different file formats, and you can save several plots at once, and there's all these things you can do. So it's just really awesome. You can make this automated system.